Assalamu alaikum everyone. So lecture number 30, and we will be talking about cellular wireless network, and our focus will be GSM. So let's talk about the development of mobile systems. We will be talking about their generation. So first generation cellular network, then the second generation cellular network, and here you can see different technologies that are being used in order to accommodate those different generations. If we look at 1G, so you can see we have AIMS over here, and if you talk about 2G, so you can see we have CDMA 1 and IS-95, and that was the enhancement of 1G. So we have more superior quality of voice as opposed to first G, and the size of the mobile stations or cell phones, they are on the they were very big, right? So, and they consume more power as opposed to the second generation cellular phones, right? So and then if we talk about 2.5G, right, so you can see we have more enhancement in CDMA, that is CDMA 2000, and in addition to voice we have the data communication over here in 2.5G, that is by GPRS. And if you look at the GPRS row, so you can see now we have TDMA, right, time. So we have circuit switching and packet switching as well when we talk about the 2.5G or 3G. And if we talk about 3G, so you can see that there are a bunch of different techniques that are lying under CDMA and TDMA. And here we have the superior quality, the most superior quality of voice data, and you can also say that we have some other services also alongside, for example SMS, right? So, and if we talk about 4G, right, so we have LTE, long-term evolution, and the data speed is kind, so it's totally based on the packet-based network, right? Okay, so let's talk about GSM. That what is GSM? It stands for Global System for Mobile Communications. It is a digital cellular communication system. So if we have GSM, this infrastructure can provide digital transmission. It has compatibility with ISDN, Integrated Services Digital Network, and we can have roaming, right? So you have one number, you can roam about, you can move from one place to another place, one city to another city. Even in some cases, or in most of the cases, I must say that you can roam all over the world, or at least within the Europe, you can do that, right? So on the basis of the GSM, right? So provide roaming in other GSM networks, and then provides a model for 3G cellular UMTS. So here we have an overview of the GSM after its definition. So you can see that it is actually founded in 1982, right? So Pan-European Standard, ETSI, European Telecommunications Standardization Institute, right? And simultaneous introduction of essential services in 3 phases, right? So there are different phases, and we have seamless roaming when we talk about GSM. And nowadays, so this is point to be noted, that nowadays most of the services, they are using GSM infrastructure. So you can talk about voice services and data services and SMS services and some other services that includes triple play services. They are based on GSM infrastructure, right? So those services are being provided by using the GSM infrastructure, right? And nowadays GSM is being used in more than 220 countries in all over the world, right? So in Asia, Africa, Europe, Australia, and America. And we have around 4.2 billion subscribers all around the world, and 700 carriers that are providing different services, right? So as mentioned, more than 75% of all digital mobile phones use GSM. So most of these services, they are being provided by using GSM, but nowadays people are talking about LTE, and it is actually it has the capability of providing very high-fi data speed, but theoretically those limits are there, but practically they are not achievable at this point in time, right? So here we have some of the performance characteristics of GSM, right? So communication, when we talk about the wireless communication, so when we have to support wireless communication with mobility, so this is the challenge, right? We have a very limited amount of power, we have limited amount of resources regarding the computational power, or there are some other resources, memory, and so on and so forth. So this is a challenge, right? So mobility alongside the limited power, limited resources is a challenge. So mobile wireless communication, and we have the support for voice and data services. Mobility, international access, chip card enables use of access point of different providers, can use the access point of different carriers, and then we have worldwide connectivity, and one number can be used, right, on different carriers, right? High capacity, so the efficiency is used efficiently, so you can see the efficiency, which is a very precious and scarce source, it is being used efficiently, and we have smaller cells, right? So as a result, we can have more customers within a cell, high transmission quality. So as mentioned that if we compare with the 1G, 2G, we have more superior quality of voice, and also some other services, high audio quality and reliability for wireless, uninterrupted phone calls at high speeds, right? So for example, we can make a call without realizing, so the communication is seamless. Even we can use this service onto trains, fast trains, right? So even nowadays we can say that we can use this service in aeroplanes, right? So then we have security, which is very important, access control, authentication, authorization via chip card and PIN number. So here are some of the disadvantages of GSM. No end-to-end encryption of user data, right? No full ISDN bandwidth of 64 kilobit per second to the user, and we have no transparent bearer channel, reduced connection while driving, right? So electromagnetic radiations, this is a must-have, and abuse of private data right? So one can abuse your private and personal data, and because whenever we are moving all around the world and we have to use services by using GSM infrastructure, so our profiles has to be mirrored to different carriers, to different locations. So roaming profiles are accessible in this case. High complexity of the system, several incompatibilities within the GSM standards, right? So standardization is also an issue, because nowadays you can see that a lot of different carriers, they are adopting different standards, right? And here the services which GSM is offering: voice connections, data connections, SMS services, even now we can say that we are able to access some other services that include multimedia services and triple play services via GSM. Then multi-service options, combination of basic services. If I'm making a call, and alongside the call I want to send some file, right? So, or maybe I want to send some SMS, right? So I can do that. And then three service domains: bearer services, telematic services, and supplementary services, right? So here is the nomenclature of GSM. Is a public land mobile network. Several providers set up mobile networks following the GSM standards. So there is not a single provider that is actually involved. So maybe the infrastructure is laid down by one provider and the data service is being provided by some other provider which has a very fast core network that can provide different data services. And then maybe we can say that onto that data and the core GSM infrastructure, there are some other providers that can provide more services onto this network, right? So several providers set up mobile network following the GSM standards, right? Components, so we have mobile station over there, right? Base station, MSC, mobile switching center, and location register or registrar, subsystems, RSS, radio subsystem, NSS, network and switching subsystem, and we have call forwarding, handover, switching is accommodated at NSS, and for at RSS, all radio aspects are targeted over here. Then we have OSS, management of the network is being performed as at OSS, right? So these are the ingredients. So main fundamental ingredient, you can say, above the infrastructure or above the core, cellular phones, but smallest part of the network, right? So if you want to use the GSM service, you must have a cell phone that support GSM. So here we have different antennas, towers, right? Okay, so here you can see different base stations, cabling over here, and microwave links. So those antennas, they actually are microwave antennas, right? So, and here we have more ingredients, right? Major part of the network investment point of view, right? So we have the management, switching unit. These are this is main switch that is performing switching, and then we have a database over here and monitoring over here, right? So here you can see we have the NSS with OSS, right, and RSS, right? So if I go back, so you can see call forwarding and switching and handover are being performed at NSS, right? So network management is being performed at OSS, right? So NSS with OSS. So here we have HLR, VLR, MSC, right? VLR. This is the fixed network, right? So we can have telephone services. For example, if somebody want to call from a fixed network to the cellular network, so this should be done, right? If we have the fixed network that is integrated with this GSM infrastructure, and somebody want to call from a cell phone to a fixed line, PSTN line, right? So again, we can do that. So here we have different cells, and each cell has its own base station, BSC over here, and here we have the elements and interfaces. So you can see RSS, NSS, right, and OSS, mobile station, radio cell, right, BTS, and this is the interface between the cell phone and the BTS, right? And you can see we have signaling ISDN, PSTN, PDN, right? And this is A and ABIs. So now let's talk about the GSM system architecture, right? So you can see that we have radio system, subsystem, network and switching subsystem, and fixed partner network, right? So we talk about the radio subsystem. So we have MS, then BTS, right? So and if we have BTS and BSC, so we can compose, we can have a BSS, and this is the interface A, this is the interface this is the interface ABIS, right? And here we have the switching and network part, right? MSC, EIR, HLR and VLR, and here we have the PSTN termination over here. So you can see SS7, right? So this is the protocol being used for PSTN, ISDN, and here we have ISDN, PSTN, and PSPDN and CSPDN, right? So you can see the components. If we talk about the radio subsystem, right, and you can see MS mobile station, right? So this is the radio subsystem, BSS base station subsystem, and in a BSS we have a BTS, base transceiver station, sender and receiver. It is acting as a transmitter and receiver simultaneously, and then we have a BSC, base station controller, right? So you can see we have a base station controller over here, and if we talk about the interfaces within the radio subsystem, so we have that is the radio interface between the mobile set, right, and the BTS. ABS, standardized open interface with 16 kilobit per second user channel, standardized open interface with 64 kilobit per second user channel. So these are the interfaces. So here we will be talking about the network and switching subsystem, right? So this is the network subsystem, right? So you see we have MSC, mobile service switching center, and IWF over here, interworking functions, right? ISDN, integrated services digital networks, PSTN, public switched telephone network. This is the infrastructure for conventional telephony, and then packet switched public data net, PSPDN, and circuit switched public data net, right? And here are the databases, right? So these are also used for billing purposes, and home location register and visitor location register and EIR, equipment identity register, right? So you can see if we talk about the radio subsystem, it is composed of mobile network up to the switching centers, and the components are base station subsystem, right? And in BSS you can see we have BTS and BSC, right? Base transceiver station, radio components including sender and receiving antenna, sending and receiving antenna. Directed antennas are used on one BTS can cover several cells, right? And then if we talk about BSC, base station controller, switching between BTS and base transceiver stations and controlling BTS, managing of network resources, mapping of radio channel because to talk about the mobile station, so the channels are allocated, and those channels are being allocated, right, via interface, right, onto the terrestrial channels. And if we talk about BSS, that is base station subsystem, so we can have BSC, right, and base station control plus we can have one or more BTS plus interconnections between BTS. Mobile station, so here we will be talking about the cellular network. segmentation, right? So you can see we have different segmentation over here, area into cells, right? So this is the cell, possible radio coverage for this cell. This is the idealized hexagon shape of the cell. So what are the advantages of having cellular or cell infrastructure? We can use several carrier frequencies, small same frequencies, so the neighboring cells will not be using the same frequency. So we are using, for example, let me write down over here F1, right here, then we can use F1 again here. So adjacent cells, right? So F1, there is a gap of one cell between F1, right? So if similarly if we are using F2 over here, so maybe you can use F2 over here, right? So now the same frequency in adjoining cells. Cell size vary from some 100 meter to 35 kilometer depending upon user density, geography of the area, and the transceiver power. So here we have the hexagonal shape of cell. This is the idealized shape, right? But if a mobile user changes cells handover of the connection to the neighboring, right? So if a user, right, so here MS1, mobile station 1, is moving from here to here, so a handover should be done. So here we have GSM and different frequency bands, right? So you can see we have the type, as we have different types of GSM channels. And when we talk about the GSM infrastructure, so two things are very important. One is uplink, and the other is the downlink. So we are using one frequency for uplink and another frequency range for the downlink, right? So you can see if we talk about GSM 850, so the total number of channels that are supported 128 to 251, and then we have the frequency range for uplink 824 to 849, and this is the frequency range for downlink 869 to 894. And here is the GSM 900, that is classical GSM, and the channels 0 to 124, 955 to 1024, 124 channels plus 49 channels, right? And these are the ranges. For uplink we can use 876 to 915, 892 to 915, and 880 to 915. And as far as downlink is concerned, so we have 921 to 960, right? So here you can see the upper limit is same, right? So again here for the downlink, upper limit is the same, 935 to 960, 925 to 960. And this is the GSM 18, right? So 512 to 885, and uplink frequencies range from 1710 to 1785, and for the downlink 1805 to 1880, and for GSM 1900 512 to 810, and the uplink, these are the channels, number of channels, and here we have uplink frequency ranges. These are 1850 to 1910, and for the downlink frequency 1930 to 1990, and here we have GSM R exclusive, right, 955 to 1024 and 0 to 124, 69 channels, right? So these are the frequency ranges for uplink, and here we have the frequency range. And nowadays lot of carriers, they support quad band GSM, right? So it means we can have support for GSM 850, and we can also have support for GSM 1800 and 1900. So they 1, 2, 3, 4, right? So quad band, right? Here we have base transceiver station and base station controller, right? So different functions that are being performed by BTS and BSC, base station controller, are distributed over BSC and BTS. So here you can see that a BSS SS can be composed of a BSC, base station controller, and there should be at least one BTS, so we can have more than one BTS, right? So here we have two BTS. So functions, management of radio channels, it is being performed at base station controller, not at BTS, right? So frequency hopping, right? So that is a spread spectrum technique. So that is supported by both by BTS and BSC. And here management of terrestrial channels, and here it is supported by BSC but not at BTS, right? Mapping of terrestrial onto radio channels, again BSC is functioning over here, not the BTS. And channel coding and decoding, so this channel encoding, channel coding and decoding is being performed at BTS, not at BSC. Rate adaptation, so perform at BTS, not at BSC. Encryption and decryption, so both support encryption and decryption, both the base transceiver station and base station controller, they support encryption and decryption. Paging, right? So again, whenever a call comes in, right? So the main MTSO, it sends paging to all the BTSs, right? So this is supported by both BTS and BSC. So uplink signal measurement, this is important and in order to take the decision, handoff decision, and here you can see it is supported by BTS but not available for BSC. And traffic measurement, BSC is measuring the traffic but not the BTS. Authentication is being done at BSC. And location registry, again BSC is working here, and handover management, again BSC, right? Okay, so here we will be talking about mobile station. This is a very tiny and intelligent component that is involved when we talk about the GSM network. So we must have mobile station in order to use these services that are available onto the GSM infrastructure. So this is the terminal that is used for GSM services, and it has several functional groups. Mobile terminal, right? So you can see mobile terminal, and with this mobile terminal we have interface that is used in order to have the interface between the BTS and the mobile station, right? So is an interface between BTS and mobile station. So MT, mobile terminal, it offers common functions used by all services the MS offers, mobile station offers, corresponds to the network termination of an ISDN access, right? It corresponds to network termination, right? Endpoint of the radio interface, right? So you can see this is the radio interface between BTS and your cell phone. And we have the TA, terminal adapter, hides radio specific characteristics, so it hides the radio specific complications. And then terminal equipment, peripheral device of mobile station, offers services to a user, right? So it does not contain GSM specific functions. And then we have the SIM, that is subscriber identity module, personalized of the mobile terminal user parameters. So we can have a user profile that can be stored onto the SIM. So now we will be talking about the network and switching subsystem component. It is the main component of the public mobile network, right? So it performs switching. So in addition to the switching, it also perform mobility management. So whenever a user has to move from one cell to another cell, right? So this is the unit where the management is being done, and that is at NSS. Interconnection to other networks. So if we want to connect to some other network, for example PSTN, maybe some other network that is using some other technology. So again, NSS is the main player over there, and then we can also have system control via NSS. So if we talk about NSS, right, so there are a lot of components that are being involved in NSS. Mobile Service Switching Center, MSC, and it controls all connections via separated network to from a mobile terminal within the domain of the MSC, and several BSC can belong to an MSC. So the database is also residing within NSS, right? And it's scalability, high capacity, low delay, right? We require certain, because the database should be scalable, right? And we must have high capacity, and the delay should be at minimum whenever there is a query for some information. Then we have Home Location Registrar, HLR, Central Master Database containing user data, permanent and semi-permanent data of all subscribers assigned to the HLR. And then we have Visitor Location Register, right? Local database for a subset of user data. So we can have mirroring of the user data, not all the data, but some part of the data whenever we have to move from one place to another place. So we will be having VLR over there, right? So, and then MSC, Mobile Service Switching Center. So you can see that we have MSC over here, plays a central role in GSM, right? It performs switching functions, right? It also supports mobility functions, right? And it actually performs management of network resources, because whenever a call is made, so resources has to be allocated. So after one of the user hangs up, the resources has to be freed. So there should be some centralized resource management that should be performed effectively and efficiently. So MSC is also performing management of network resources, interworking functions via gateway, and then integration of several databases. So here are the functions, specific functions for paging and call forwarding. So whenever a call has to be done, then the main MTSO, it sends paging messages to all the BTS corresponding BTS by looking at the number. So specific functions of paging and call forwarding is a part of MSC. Termination of SS7. So if you look here, you can see that SS7 is connected with MSC. So it is actually terminating SS7, signaling system number 7, and we have mobility specific signaling, because whenever a handoff should be performed, so first there is a dialogue, there is a signaling phase between one BTS, you can say local BTS, and the BTS where the user intends to move. So there should be dialogue signaling between the current BTS and the BTS where the user intends to move, right? So the mobility specific signaling is handled by MSC, and then location registration and forwarding of location information, and provision of new services if you want to add new services. So again, we have to rely on MSC. Support of short messages services, so it also support SMS generation and forwarding of accounting and billing information. So this is again the part of the MSC. So operation subsystem OSS enables centralized operation, management and maintenance of all GSM subsystem. The components that are involved: authentication center, right, and VLR, authentication parameters used for authentication of mobile terminals, and encryption of user data on the air interface within the GSM center system. Equipment identity registrar, again this is part of OSS, right, and here we have within the equipment identity registrar EIR, we have register mobile phone stations and the user rights, right, and if there is some phone that is stolen or there is some malfunctioning, right, at the mobile station, and as a result it cannot have services, right, so it is being locked. Operation and maintenance center, different control capabilities for the radio subsystem and network subsystem. Okay, so here we have the protocol stack. So after discussing the architecture, so we'll be talking about the protocol stack. Signaling is very important when we talk about the telecommunication system. So even if we take the example of PSTN calling, right, so one user has to make a call to another user, right, so you can see whenever we pick up the receiver, so we can hear the tone and we dial the number, so we have to wait, and there is a bell ringing across the other side of the phone. So this time that we normally call the call setup time is very important. So during this time, actually the signaling is being performed. The two endpoints, they are exchanging data, or maybe the central exchanges or these exchanges which are involved within the call, or you can say the one leg of the call or the other leg of the call, right? So there is a phase of signaling or call setup time between before the actual communication start. So signaling is very, very important, right? So it is actually the phase whenever the end parties, they dialogue and they set some rules of communication, which codec is going to be used for this communication. What are the capabilities of the endpoint? What are the protocols that can be supported if we are talking about different services? So we have to coordinate all the corresponding information during this signaling phase, right? Distributed functions. The transfer of signaling information in GSM follows the layered approach. So again, we are following layered approach, right? So the signaling information is also following those different layered model, right? So we have physical layer, radio transmission, then we have data link layer, DLL, error-free transmission between adjacent entities based on ISDN, LAPD, right, and interfaces that are being involved. Then we have networking or messaging layer, that is the layer 3, and this layer is responsible for the communication of network resources, mobility code format, and caller related management messages between various network entities, right? So okay, so here we have the protocol architecture. So you can see we have 3 layers. Layer 1, that is radio, layer 2, that is data link layer, and then we have layer 3, right, networking and messaging layer, right? So you can see CM, connection management. If you start from the top, right? So then mobility management, and here then after that we have RM, radio resource management, and after that we have layer 2 we have LAPD, and here we have radio, right? So MTP, message transfer part, and LAPD, link access protocol, right? SCCP, signal connection control part, and these are the interfaces, right? Air interface, right? UM, and this is another interface, ABIS, and here we have A. Radio interface between mobile station and BTS, base transceiver station, and each physical channel supports a number of logical channels, right? So this is the interface between BTS and BSC, ABIS, and primary function of this interface is traffic channel transmission, terrestrial channel management, and radio channel management. Then we have another interface between BSC and MSC, right? So between BSC and MSC, right? So primary functions of this interface, message transfer between different BSCs to MSCs, right? So let's talk about some of the interfaces. The data link layer 2 over the radio link is based on a modified LAPD, link access protocol for the D channel, as LAPDM, right? M like mobile. So if we talk about ABS interface, the layer 2, it's a layer 2 protocol that is actually based on LAPD and from ISDN. And then we have message transfer protocol, MTP, level 2 of SS7 protocol, and it is used at the interface A. So here we will be talking about the user data and control at air interface, right? So two type of ISDN channels or communication paths. First is B channel, bearer, and here we have the D channel, or that is delta channel. So if we talk about bearer, B channel, a 64 kilobit per second channel used for voice, video, data, and multimedia calls. So we can have voice, video, data, and multimedia calls by using bearer channel. And then delta channel, a 16 kilobit per second or 64 kilobit per second channel used primarily for communications between switching equipment in the ISDN network and the ISDN equipment. So this channel is actually used for carrying the signaling information between different devices and interfaces, right? So here we will be talking about user data and control at air interface. So here if you see, we have the user data, right? And these are the different layers, layer 1, 2, 3, and we have this interface, BM channel for traffic per user data, DM channel for signaling over here. You can see this is the DM channel. So in ISDN, the DM channel can be used for user data if capacity is available, right? So you can use this data, this channel, DM channel, for user data if capacity is there. Okay. So here we will be talking about the layers. Layer 1, physical layer. Radio transmission forms this layer. So we have the physical interfaces and radio transmission that are relevant to this layer, physical layer. So you can see we have radio functionalities at MS and BTS, right? BSC and MSC, right? And here we have modulation techniques that are involved. So if we talk about the GSM, so we actually use Gaussian minimum shift keying, and then we have channel coding, block codes, and convolutional codes, and then interlevers are involved in order to distribute the burst error. So we use interlevers. And then we are adopting different power control methodologies at physical layer in order to minimize the co-channel interference, and then we also perform time synchronization approaches at the physical layer, right? So we have modulation, channel coding, interleaving, power control, and synchronization, time synchronization at physical layer. So here is the architecture for speech if, right? So you can see that we have different protocols that are actually lying at different components, right? Different places. MS, we have GSM voice, FEC, cipher, TDMA, and FDMA, right? Talk about BTS, GSM voice, right? FEC, forward error correction, cipher, TDMA, and FDMA. And here you can see ISST and voice, right? G703 codec, and then G705 codec, and G732 codec. At BSC, we are supporting same set of codecs, and at MSC, same codecs. And you can see the interfaces ABS and A over here. So if we talk about the layered approach, right, and by taking into account mobile station, right, so is digitally coded at a rate of 13 kilobit per second. So here we have signaling and voice speech, right, channel coding, interleaving, bus formatting, ciphering, and modulation. So Gaussian minimum shift keying, right? So this is the RF front end, and the signal is transmitted, and then this signal is received at the receiver. Demodulation, deciphering, bus deformatting, deinterleaving, channel decoding, right? So, and we will be getting the original voice if it is the voice, and we will be getting the signaling data if it is the signaling data. So here are some of the formats, right? So you can see we have bus formatting, right, interleaver, channel encoding, right, over here, and normal bus formatting, right? So you can see A, B, C, and bus training sequence over here, and here we have talked about GSM frame hierarchy: hyperframe, superframe, multi-frame, and this is frame, and this is the time slot that is actually allocated, right? And if we talk about the because there are channels that actually physically we have one channel, but we divide the physical channel into logical channels, are all available, right, for all time slots of BTS, with 6 carriers has 46 physical channels. So logical channels are piggybacked on the physical channel. Logical channels are laid over the grid of physical channels, right? Performs a specific task. So if we talk about the logical channels in GSM, so we have two major classifications: traffic channel, TCH, and control channels, right? So again over here we have this is the traffic plane, and this is the control plane. Traffic channels, two type of TCH, right? So full rate traffic channel and half rate traffic channel. And then we have also classification of control channels in so here we have the traffic channels classification, control channel classification, broadcast channels BCH, common control channel CCCH, and dedicated control channel DCCH, right? So here we have the second layer, that is the data link layer, and it actually ensures error-free transmission between different interfaces, between different components, and you can also say between different interfaces that are involved within the infrastructure, right? So the purpose of data link layer is to check the address and sequence of packets for layer 3, right? So in addition to that functionality, it also manages acknowledgements for transmission of packets, right? So, and a signaling packet delivered to the physical layer is 184 bits, which conforms with the length of the data link layer packets in the LAPD protocol, and that protocol is used in ISDN network, right? So this protocol is also used for A and ABS interface. The DLL data link layer is the UM interface for the UM interface, right? So the DLL data link layer for UM interface is LAPDM, right? So you can see over here LAPDM, right? So over here M for mobile. The link access procedure on the DM channel is the protocol used by data link layer on the radio interface. So here are the functions. Organization of layer 3 information into frames, so it organizes frames, right? And then peer-to-peer transmission of signaling data in defined frame format, recognition of frame format, and then establishment, maintenance and termination of one or more data links on signaling channels, right? So tearing down the data links on signaling channels. So here is the frame format for LAPD. So you can see octet 1 opening flag, and then octet 4, 5 we have structure of the control field, depends on the frame type, and octet 6, right, layer 3 information is only presented in layer 2 information frame, right? So closing flag over here. So this is the frame format. So we will not go into more details about those different frames. And then we have layer 2 messages over here. So set asynchronous balanced mode, disconnect, unnumbered acknowledgement, receiver ready, receiver not ready, and reject. So these are the layer 2 messages. And these messages are sent actually in peer-to-peer layer 2 communication, right? Have layer 3 information bits, right? So here we have some other layer 2 messages, paging channel, right? 176 bits, right? And then we have the standalone dedicated control channel, right? And then we have the slow associated control channel. So here is the layer 3 are used, actually layer 3 protocols are used for communication of network resources, mobility management, mobility code format, and call rate management messages between various network entities, right? So here are some of the mechanisms that are being performed at layer 3, a number of mechanisms that are required in order to establish, maintain, and terminate a mobile communication session. So first we have to initiate a session, and then we have to maintain that session throughout the communication, and then after the communication is over, we have to terminate the session, right? So layer 3 implements the protocol that are required to support these mechanisms. A signaling protocol, of course there should be a signaling dialogue between the communicating parties. The registration process is composed of a sequence of communication events or messages, details of implementation of messages on the logical channel, right? So here we have layer 3 message format, transaction identifier, TI, protocol discriminator, message type, and then information elements. So these are different messages, and you can have different layer 3 messages, right? Category, message, direction, and this is the message type, MT, right? Radio resource management, RR, mobility management, MM, and connection management, CM. So you can see CM, MM, RM. So radio resource management sublayer handles all the procedures necessary to establish, maintain, and release dedicated radio connection. Channel allocation, whenever we have to perform a handover, right? So we actually are relying on this radio resource management, and then timing advance, power control, and frequency hopping. So mobility management, right? It assumes a reliable RR connection, radio resource connection responsible for location management and security, and then we have location management and security that involves the authentication and encryption as well. Connection management, call control, supplementary services, and short message service, right? So here we have call control sublayer, connection management, right? So you can see supplementary service sublayer and SMS sublayer. Okay, so we will be talking about, now we'll be talking about different patterns that we are going to introduce in order to divide the area, coverage area, into small cells, right? So here we have different patterns. So these are the circular patterns, so you can circles, and these are equilateral triangles, and here we have squares, hexagons, right? So these are different geometry, right? And cellular use low power transmissions if we divide a huge cell into small cells. So of course we need small power for transmission. Each cell is allocated a band of frequencies and is served by its own antenna, as well as a base station consisting of a transmitter, receiver, and control unit. So here we have hexagon reuse cluster, right? For uniform hexagonal cells, tessellating reuse cluster of size n can be constructed if n is equal to I square plus I into j plus j square. Non-negative integers such that I is greater or equal to 1 and I is greater or equal to j. For n is equal to 1, 3, 4, 7, 9, and 27, and so on and so forth are allowable cluster size, right? Thought of as the reuse factor in 2D system, right? So k cells and a total of m channels with a reuse factor of n, right? The total channel capacity is C is equal to m over n into k, right? So here we have frequency reuse. So this here we have one frequency at B cell, and this frequency can be reused over here, not within the neighboring cells, right? So these are the fictitious cell patterns, and this is the ideal set pattern, and this is the real cell pattern, right? So you can see the D-shaping of the hexagonal cells. So each frequency is having different color over here, and we can see the color is repeating after, right, number of cells, right? So not adjacent cells are colored same, right? So if you can see over here, this one frequency, for example, F1 is being used over here, and we want to use the same frequency F1 over here. So you can see here we have the I step, right, 1, 2, and here we have the J step, 1, 2, right? So you can see R is equal to cell radius, area of hexagon is equal to 2.61 R square, distance to co-channel cells, right? So this is the distance to the co-channel cells, right? So if this is co-channel 1, right, and here we have the same number. So now we will be showing reuse pattern, right? So here you can see we have 3 cell reuse pattern, I is equal to 1 and j is equal to 1. So if I go here, right, so if I have to talk about, so you can see I is equal to 1 and this is j is equal to 1, right? So I is the movement in this direction and j is the movement in this direction. So here we have I is equal to 2 and j is equal to 1. So if I have to go here, right, so j is equal to 0, so I have only this movement 1 into 2. So there is no movement in this direction, right? Let me draw the line with dotted lines, right? So if I move here, right, so only movement in the I direction, I is equal to 2, and there is no j, because we normally have movement of j in this direction, right? So for cell reuse, so you can see A, B, C, we have A, B, C, and D. So here we have 12 cell reuse, so you can see I is equal to 2 and j is equal to 2. So this is 1, and 1 is repeating over here, 1, 2, right? So I is equal to 1 and 2, and then if we talk about j, so 1 and 2, right? So j is equal to again 2. So here we have I is equal to 3 and j is equal to 2. 19 cell reuse pattern. So you can see I is equal to 3, 1, 2 and 3, that is I is equal to 3, and for j 1 and 2, j is equal to 2, right? Okay, so here we have the relationship between Q and N. So first we need to know what is Q and what is N. Q co-channel reuse ratio, and D is defined over here as frequency reuse distance, R cell radius, and N number of cells per cluster, and 1 over N is the frequency reuse factor. So then we can find Q, that is the co-channel reuse ratio, is equal to D over R. Okay, so here we have some of the factors limiting frequency reuse, co-channel interference, and adjacent channel interference, right? So interference, adding new channels, so we can add new channels and we can borrow frequency from the neighboring cells, adjacent cells, if we have a lot of traffic. We can also have cell splitting and cell sectoring, right? And we can also construct microcells. So you can see we have cell splitting over here. So this is the configuration, right? So this is the 360 degree. You can see omni cell, right? So this is the C sector cell, right? You can see 3 sectors. The C sector sectorized cell, and 2 sector sectorized cell, and handoffs, right? So handoff is very important mechanism. So whenever one mobile station is registered with one of the cell, and it is on the move, and of course it will be moving from one cell to another cell, right? So the base station within that cell, right, and the base station with the neighboring cell, right, so they all are will be aware of the situation, and they will be continuously or periodically calculating the parameters, different parameters, right? Or you can say they are capturing different parameters so that they can perform the hand off, right? So actually when the user will move from one cell to another cell, so they should be seamless hand off. The underlying communication should not disrupt, or the underlying service that is being used by the customer should not be disrupted. So the handoff should be seamless, right? It means that there should be no obstruction in the service. So refresh and renew paths as mobile station host moves between cells. Handoffs are functions of one cell handing over the communication link between itself and a mobile station as the mobile station moves out of the boundary of its region into the boundary of an adjacent cells, right? End-to-end connectivity, right? So it should be seamless, right, in a dynamically reconfigurable or reconfigured network topology. So here you can see intra BSC handover, right? So This is one use case, and here we have inter BSc but intra MSc handover, and here we have inter MSc handover, right? And so you can see two MSCs are there, right? So here we have inter BSc, two BScs are there, right? Okay. And then we can avoid the handoff if we have umbrella cells, right? Large umbrella cell for high speed traffic. And then of course when we talk about the GSM, you have to follow certain techniques, methodologies, mechanism and techniques. So first of all, encoding, that is the modulation. So we have different types of modulations: amplitude, frequency, phase, right? And we all know. Then we have some other types that are amplitude shift keying, frequency shift keying, and phase shift keying. So these are used when digital signals are used, and these are used, right, when we have a regular wave. Okay, and then we also have to perform multiplexing. So there are a number of multiplexing techniques when we talk about GSM. So we have time division multiplexing over here, and CDM, right, score division multiplexing over here. And these are the techniques. So if we talk about the encoding multiplexing, right, frequency division multiplexing, channel given to each user, right? So here we have the more details regarding time division and code division multiplexing. So in time division multiplex, it involves a channel with a given number of time slots. So each channel is allocated a time slot, right, where each user is assigned current time interval. Whenever we talk about CDM, it gives each user a code for different purposes, right? So each user has its own code. So it picks up each channel from the noise using the code. Wide frequency band is used, does not contain single frequencies, time slots. So here are some of the analogies. If we talk about FDMA, TDMA, CDMA, right? So you can see if everyone talks in a different room to prevent interference, that is, you can see every user is assigned a different frequency, right? So prevent interference. Conversation can't be heard from another room, right? So if we talk about the TDMA, right, each room everyone takes its turns, so everyone is allotted a particular time slot. So this is TDMA. So everyone is speaking within a single room, but they are using different languages, right, at the same time. So the language is unique, one may be filtered from another, right? So here are some of the advantages of code division multiplexing, and here we have some of the disadvantages, and we can have some sort of analogies. So here we have the steps that are involved in GSM location services. Call made to a mobile unit, cellular phone. So you can see here, so we are calling from a PSTN line to a cell phone user, right? So telephone number, network recognizes number and gives to gateway MS, right, MSC. So this is the gateway MTSC, and this is the terminating MSC. MSC can't route further, interrogates users HLR, right, visiting location, right, and currently serving user, right. So here you can see 2 and 3, and here we have the 4, and then we have the 5 over here, right, 5 simultaneously from VLR to HLR and HLR to gateway MSC, right. And then on this 6th step, call routed to terminating MSC. This is the terminating MSC. VLR to correlate call to the subscriber. VLR complies, right, and the mobile unit is paged. So now paging message is sent by the MSC, right, and response MSC conveys, and the call is established between this user and this. So that's all for today's lecture. Today we talked about GSM and we discussed the architecture of the GSM, and we also talked about the interfaces, different components that are involved within the GSM infrastructure. We talked about the layered approach that is actually being followed in GSM infrastructure. Then after that we talked about cell pattern and how we can use the frequency resource, which is a very precious resource, in order to have cell sectoring and partitioning. And then after that we talked about different protocols and different messages that are involved onto those different layers, right? And finally we talked about the scenario where we can perform the handoff, and we also discussed different types of handoffs that are involved when one user has to move from one cell to another cell. So that's all. अपना ख्याल रखिएगा. मेरी तरफ से अल्लाह हाफ़िज़. अस्सलाम वालेकुम.